we need to learn about functions.
Yay. Fun.
No, not functions again.
Yes, functions again.
Functions.
So, functions are one of the few things that I'm not going to lie to you about at least a little bit in this class.
And they never go
There's a
away.
lot of like caveats and addendums to math. Functions, the way that we're presenting them, is kind of legit. This is the way functions work. So this is what the rest of math studies, essentially.
So now, fun.
So this is the kind of outcome I expect from the course, that you know what a function kind of is and does and can play a little bit with functions. Cool? Okay, so the idea is relatively easy. The execution gets a touch more complicated, but not so bad. The idea is this. I've got some inputs, right? We might even think x's on these. And then we're going to do something to them. We're going to apply some kind of a rule f. For f, we might think, well, in some sense, this is like a machine. Right? It takes some kind of input and outputs something else, right? So what do we call this side?
Output.
Yeah, outputs, right?
Range.
And so there's some words for these. We call this
Domain.
the domain. Right? That's all the things that can fit in. And this thing we call the
Range.
range.
Fancy.
What do we think when we look at outputs?
Why?
Yeah, we might think y's. I'm going to try to steer away from that because I want to think about the y-axis, right? The height on our plane as being y's. These are going to be specific heights, so I'm going to think about these as being, well, I don't know. I started with x. I did f to it. I'm going to write f of x,
Sure.
right? So this is symbology that we need to remember. When we write a rule name and an input with parentheses, what we should think to ourselves is that this guy is the rule f done to input x. And we'll say that as f of x. You guys with me on that? Ish? Do you want an example?
Yes.
Okay, so here's an example of a function. F of x is 2x plus 3. Okay, so what do I mean by this?
2x plus 3.
Is the what? What's 2x plus 3?
Function.
Yeah, that's the function's rule, right?
Okay.
So this is telling me that the rule f done to x's is twice x plus 3. You see that? So if I took some x's and did f to them, right? I could think here, these are the inputs, right? These guys are the outputs. So what are your 5 favorite numbers? And let's try this thing out.
0.
0 is good.
1.
2.
Negative 1.
Negative.
60.
Negative 2.
Thank
Good.
you.
5 favorite numbers. These are the usual test numbers. So when I say something like, let's try our favorite numbers in this thing just to see what it does, these are the ones I would suggest you try. I would steer away from bigger numbers because personally I'm bad at multiplying big things together. All right, so what do I get for that? wait, hang on. What's 0?
It's nothing. What are you asking here?
Okay, so 0 as an input yields 3 as an output, right? So here I'm thinking of 3, right, as 2 times 0 plus 3. See that? Yeah. Okay, what do I get when I plug 1 in? 5, which we're thinking of as
2 times 2.
2 times 1 plus 3. Okay, how about,
7.
what's 7?
It's going to be the
2.
It's going to be the output of the input 2, right? So for this, I'm thinking this is 2 times 2 plus 3. Okay, how about negative 1?
1.
I get 1 out when I put negative 1 in. And when I put negative 2 in, I get negative 1 out. Very nice. Cool. So here we're thinking 2 times 1 plus, oops, 2 times negative 1 plus 3. And here we're thinking 2 times negative 2 plus 3. Is cool with this? Okay. Let me give you 2 more examples of functions. A dumb one, and then a maybe more everyday kind of thing.
dumb.
Dumb one? Here's a dumb one. Here's a little machine. This machine paints stuff blue. Okay? So if I ask you a question like, what's the domain of this thing? What are the possible inputs for the blue machine?
Anything not blue?
Can I fit blue things in the paint it blue machine?
Yeah, you can.
Sure, it doesn't change them maybe, right? But as long as I can fit them in there, they're legal inputs for the blue machine, right? So really the domain is,
Anything.
All real.
Anything legal.
yeah, whatever you can fit in the blue machine, right? So, this is kind of a dumb thing, right? To state this, whatever fits in. But that's really what we usually say for the domain. We say it's the set of inputs that work, right? The ones that make sense. How about the range?
Whatever plus blue.
Kinda. What are the things I can get out of the blue machine?
Whatever you put in plus the blue thing.
Yeah, really, the only thing I can get out is blue stuff, right?
Whoa, whoa, whoa. What if you put something yellow in there, though? Then it's going to be coming out green, and we're going to have a huge mess on our hands.
No, we paint with clearly opaque paint.
Got it.
You guys get this? So the domain's whatever you can put inside, whatever we can fit in the rule, and the range is whatever we can get out. Cool? All right, you want a more reasonable example? Like a more mathy example?
Kind of like these dumb ones, actually.
I hope you like the dumb ones. They're really the thing you should think of. When you're trying to figure out the domain of a function that's given by some nasty rule, really you should think to yourself, well, I can probably fit most things in this, so what's going to cause me a problem? Right? You're really going to look around for things that are too funny shaped to fit in the machine or something. So the maybe real world example is something like p as a function of t is given by some formula.
Okay.
Do you guys want to see a formula and be a little bit, are you going to be a little panicky if I put down a formula, or you be okay? Be okay? All right, suppress this from your mind if this is scary. We're going to play with this in chapter 11. For right now, this is a bunch of gobbledygook that you haven't seen before, right?
Handwriting is
Well, it's to the
No, it's supposed to be like that.
super.
That's the open space.
So-
too.
This is a P with a 0 decorating the bottom of it.
P of
The
U.
green.
And this is an E with a little r and a T in the exponent.
You're really,
Subscript and superscript.
For real.
well, I know.
This is what biologists call the PERT model.
Part.
Yeah, this is for exponential growth. So what this does is it takes a time and outputs a population based on this P0 is the initial population, and this little e is some kind of a growth rate. You guys okay with this? So the idea of this, the thing I'm trying to get at, is that this thing, right, takes input. What's the input on this?
P.
T.
Yeah, it's a T, right?
T.
You guys see that? The rule's name is P,
My bad.
right? So this is the rule P done to the input T. So this place over here is T, right? And these guys are presumably, what's T probably stand for?
Done.
Yeah, it probably stands for time, right? So this is a function that's going to take a time and turn it into a, well, I told you this was a P, right?
Mhm.
And I said something about population. This probably stands for population. You guys see this? So this is a rule that associates times to populations. What good would that be?
Trying
Dates.
to watch like stuff grow.
Yeah, I can figure out how much food I'm going to have, or how many people there are going to be to eat it, or what the half-life of something is,
How fast bacteria grows.
how many bacteria there are going to be in my petri dish tomorrow, stuff like that. Maybe better yet, I could use this to figure out how long I have to wait to get a certain amount of bacteria in my petri dish, which might tell me something like, how long do I have to wait before I'm sure there wasn't any, right? Like if I know how many bacteria make a visible spot, I can do a little fiddling and figure out that if it isn't there in 3 days, it probably doesn't need to be there. Cool? So this is the usefulness of functions a little bit. The idea, though, is just that there's a rule, it takes inputs and turns it into outputs. Cool? All right, I'm going to write down some definitions that are maybe a little wordy.
Okay, so
These are important definitions. These are really the only definitions that I'm going to be super annoying about during the course. I would recommend that you commit them to your memory like they're a phone number, right?
We don't memorize those.
Put these in your head, for real. I know you, yeah, kids today are not knowing phone numbers. Put it in your head the way you put hashtags in or something. Nobody, you guys don't remember hashtags?
I do.
We've already moved on to the next thing.
Tic-tac-toe?
Moved on to the next thing. Okay,
Yeah,
So-
it didn't take time.
Jesus Christ.
stop it. So a function is a rule associating inputs to outputs. Right? This we've said. There's one little caveat to this, which is with each input associated to one and only one output. This is the thing about predictability. I really want my functions to be predictable. So I want, if I give it the same input later, for it to give me the same output. I would also like each input to go somewhere, right? If I put an input in and the machine loses it and just doesn't return anything, it's not working. That input probably wasn't in the domain, right? It wasn't a valid input. So what I mean here is that each valid input gets an output, right? and that there's only one thing, so if I re-input it later, I get the same thing. Cool? The non-example of this is the little funny machine that looks like, wow. Cool. You guys know this machine? You put in a 50 cents or
Oh.
something. It looks like a big ass gumball machine.
Yeah, gumball.
But you put in some money and then you twist the thing and it gives you a little plastic egg with something random inside, right? So that's a machine that turns 50 cents into God knows what, right?
A sticky hand.
Yeah, a sticky hand, or next time it's a little spaceman, and next time it's one of those temporary tattoos, right? This thing's not a function. You guys see that? Because it's not predictable, right?
Interesting.
Not a function. Good? All right. We need definitions for domain and range too, even though we've already kind of said those. So the set of all inputs is the domain. Realize too that each of these is associated to a function, right? So for a particular function, the domain might change. You guys all see that? Kind of inputs that are allowed depend on the formula that you're given. The set of all whats is the range. Okay. Outputs is the range. Cool? Okay, there's one more that I need you to know. And it's this one, that the graph of a function f is the set of points Anybody remember?
Oh, am I allowed to answer?
Yeah, go for it.
X, f of x.
Okay. If you go look at the practice test for this class, you'll see that each of these, this whole block of definitions, is on each exam. Okay? Put this in your head. It's free point. It will appear on the exams. Cool? So, what's this business about an x comma f of x point? How could I think about that?
Because x equals y.
Horizontal.
Yeah, that's a horizontal and a vertical, right? An x
Yeah.
and y pair. I might think about that as an input output pair, right? That's a way for me to kind of quickly summarize what a function does. Right? If I'm not going to make one of these nasty little tables, because like, say I have, numbers, and I can put all the numbers in, do I want to spend the time to write down all the numbers in that table? No. In fact, I can't spend all the time to write down the numbers in the table, because there are infinitely many numbers, right? And I'm not going to be done. Do you all see that? So, one way I can summarize a function's data is by writing down a rule for it. Like before we wrote down f of x is 2x plus 3, right? This was our example from before. This is writing a rule down. This tells me how the function acts, right? Another way I could do that is I could write down a picture that describes that rule. You guys remember the graph of this? How about what is that thing? How about what's y equals 2x plus 3? That's a y equals mx plus b form, right? That's a line. With what? It's got a slope of 2 over 1. We're a little rusty from winter break. That's okay. So it's a slope of 2 over 1, which means that for every 1 unit of
Right.
Distance.
Run.
okay, so we're thinking here that this is 2 over 1, right? And then we're thinking that's
Rise over run.
rise over run. So for 1 run, I get 2 rise. And where does this thing start?
Zero.
Three.
Well, I mean,
So the y value, right, the f of x output for 0 is 3.
could be
So I know this point, 0, this point, 0, 3, right? 3 is the y-intercept. That's what that b does. You guys remember that?
Yeah,
And so from this point, I go over 1,
up to.
up 2. So here's my line. This line is the graph of that function. You guys see that? So if we remembered that table we had earlier, we could go find all those points. They're all on there. Right? This is 1, comma 5. And it's no coincidence, right, that when I plug 1 in here, I get 5 out. You guys all see that? Okay, so this is what I want you guys to take for functions.